Sure. Thank you, Chester, for the introduction. And I would like to thank Big Data Analytics Group and also the IOPI for hosting this. Okay, so my name is Haoyuan, you can call me HY. And I'm going to talk about this system called Tachyon. It is a reliable memory-centric storage system for big data analytics. And this is a joint work with Li, Matei, and my co-advisors, Scott and Yang. And I'm from the AMPLab, as Chester said, and this on the right side is the logo we recently got for Tachyon. So this is the outline of the talk. So at the beginning, I'm going to give a brief overview to the system, and then I'm going to talk a little bit about the research. Then I'm going to move on to our open source status, as well as what's the future roadmap. Okay. So first of all, memory is the king. On one hand, RAM throughput increases exponentially every year. On the other hand, disk throughput increases slowly. This means that memory locality is the key to achieve interactive response time. This has been realized by many. Say, for example, we have a Spark, which has been used by many companies. And there are like Impala, HANA, and many other, like they are posting about like memory-centric storage systems. So then the question is the problem really solved? So then let's take Spark as an example. So Spark is a in-memory data processing framework, and it keeps only one copy of data in memory and tries Lineage, which used to derive the data. Upon failure, it will use the Lineage concept to recompute the data when necessary. Say in this particular example, for the upper left side, say this data got lost, and then the framework will simply just recompute it and get it back. So that is great. It helps a lot of workloads, but there are still several issues. Say, for example, the first issue is like, say, in a company, you have a data process pipeline, right? So you have different Spark jobs. One job will produce the output and read by the other job as the input. So in this case, say on the left side, you have one job of some data, and then the other job on the right side load the data. This sharing process is slow. That's the first issue. So the problem is even more complicated. Say you have some legacy code it's written in MapReduce. So you want to share the in-memory data between Spark and Hadoop. MapReduce is also slow. You have to go through an external storage system. So that's the first issue. So the second issue is in a system like Spark, they co-locate the execution engine and storage engine in the same process. This means that if your execution engine crashes, the data also in-memory data also got lost, right? So you will lose all the cache, in-memory cache. You have to load the data or recompute the data again, which could be slow. So for the third issue is, even say you have two Spark jobs or more Spark jobs, right? You want to load the same data. You want to have the same input data. So what will happen is for now you have to load the data into every single process owned like JVM. So this leads to the in-memory data duplication. And then because you have more data in memory in Spark, it will trigger more often garbage collection, which will screw the performance. That's a third issue. So all this like motivated us to do this system called Tachyon, which is reliable. We want to do reliable data sharing and memory speed within and across frameworks and jobs. So then this is one slide solution overview. So the basic idea is one push the Lineage concept into the storage layer, and in the meantime we want to use the memory aggressively. Then this leads to the fact that so only one memory copy in memory, and also we rely on the Recomputation to do the fault tolerance. So then this is the picture to show where Tachyon sits in the stack. On top of Tachyon, we run different computation frameworks like Spark, MapReduce, and others. And below Tachyon, it will be like existing like storage systems like HDFS, S3, GlassDFS, OFF, or others. And Tachyon sits in the middle. And then this is the architecture of the system. So basically, Tachyon is a single master architecture, which is very simple. You have a single master which tracks the location of every each file and also the status of every node. And then on every node, we run a worker daemon which really manages the local space, local in-memory space. And then besides worker daemon, we also run a RAM disk to do the real I/O. So when the application has the memory locality, it will access RAM disk directly without going through any intermediate process. Also, we use the zookeeper to do the master fault tolerant. Then with this system in the picture, so we're going to address the issues we mentioned at the beginning. The first one is how different frameworks share the data at the memory speed. So now you have the one program generate data and write into Tachyon at the memory speed and load from Tachyon at the memory speed too. And this whole pipeline is at memory speed. The second issue, say you store the data in Tachyon, so if something got crushed, right, you still have the data in Tachyon's memory. Next time you still load from memory. And third issue is, say, because you keep most of the data in Tachyon, so you don't have much, this significantly reduce the GC issue. And also, you don't have the data duplication issue in this case. That's the overview of the system. And then let's talk a little bit about research. So we talk about Tachyon also keep the lineage concept at the storage layer. What's the lineage here? So it's basically relationship among different files. Say you have a file set A and you have a spark job read A and generate B, and you have another spark job read C and generate D. And then you have MapReduce job read B and D and generate E. This whole relationship is called lineage. Tachyon remembers this. And then by using this, we can have the memory throughput write performance. And then for the write performance, this is the picture in our prototype. So this has not been fully released yet, but this is what we will see in the future. Say in the Tachyon write, you have the memory throughput, and then for the in-memory HDFS deployment, it's like the right line here. And then we further like show what's the performance improvement even for a single Spark job. Say in this particular case, we run a single Spark application on a single machine with 240 gigabytes memory. So you can see that we run this on in three different modes. For the blue line, that's the Spark cache deserialized mode, and the green line, that's the Spark cache serialized mode, and then the red line, that's the Tachyon mode. So as you can see at the beginning, so the x-axis is the data size in gigabytes, the y-axis is the execution time, and the bottom graph is a enlarged area of the left part of the upper graph. So as you can see that at the beginning, so the Spark cache mode performs a little bit better than the Tachyon mode. But when you have more data in memory, so say for example, for the Spark cache deserialized mode, we couldn't handle more than 40 gigabytes data, raw data. And for the Spark serialized mode, it's hard to handle more than 90 gigabytes. But for Tachyon mode, you can handle 180 gigabytes. And also, you have a lot of performance gain when you have a lot of more data. That's one example of the performance. And then we also have, as I said, we have the master fault tolerance. So this is after detecting master failure. So the system can recover from the master within 1 second. We tested from 1 million files to 5 million files. And also, since I said Tachyon relies on the recomputation to achieve the fault tolerance, one natural question to ask is, you have a large cluster, there are machine failure every day. So how much resource will be used for the recovery, recomputation? So we did a theoretical analysis based on the Facebook data analytics cluster trace and the bin workload trace from Microsoft. So the result is you will spend less than 1.6% of the cluster resource, even you have a 5,000 machine cluster. And with every single machine has 1 terabyte data. So this means that you don't spend much like a cluster on the recomputation, especially considering that the normal utilization for the cluster usually is around 30% nowadays. Okay, that's done about the research. Let's talk a little bit more about the open source. So we open sourced the system like last April in 2013. And now we just released 0.5 last weekend, and this is to show that it's real from GitHub. And we have more than 15 companies contributing to the code base. And if you have a Spark or MapReduce applications, you can run on top of this system without any modification. And to show the release growth, So last April we had a 0.2 release with 3 contributors, and then we had a 0.4, that's 0.2, and we have 0.3 with 15 contributors last October, and then we had 30 contributors February this year, and for last week for the 0.5 release we have 46 contributors. And one more thing is we have a very open community. So the project we started from AMPLab at UC Berkeley, but now more than 80% of the contributors they came from outside of Berkeley. Also from Spark 1.0, so Tachyon became the default of the heap solution, storage solution for Spark. You can see this from the Spark documentation. I will show you later how to use this with Tachyon. And also thanks to Red Hat, so Tachyon now is also in a Fedora distribution. This means that if your machine connects to the Fedora repo, you can just use one command to install the system in your machine. And also the system is also commercially supported by a company called Tachyon. They provide the open data analytics platform for various industries, and they have been running Tachyon intensive clusters for their customers. And also this is a blog from Database authored by the company called 0x Data. So they use Tachyon to share the data between Spark and their own machine learning framework called H2O in this case. And also just to show that how easy to use the system. So this page shows that how do you use these different frameworks without Tachyon before. Say for example like Spark, MapReduce, and Shark. For Spark, you just start a new RDD with Spark context.txt file, and then you give a HDFS URI, and then with Tachyon, you only change the URI to be Tachyon URI. That's the only thing you need to change. It's pretty simple. And also to show that how to use Spark OFF HEAP with Tachyon. So in this case, the first one is how you have the input data from the Tachyon memory, and the second one is you call the file.persist OFF HEAP that will store your RDD into Tachyon, and next time you load from it. Okay. And here, thanks to our contributors, they are great from various companies, and a lot of companies nowadays also put full-time employee on the project. Okay. So then I'm going to talk a little bit about the future of the project. So what's the first question is what's the goal of the project? Our goal is really simple. So we want to provide assistance to other components to accelerate the whole stack. Say in this case, we want Tachyon to say, we want all these frameworks to run on top of Tachyon, like MapReduce, Spark, Test, Shark, GraphX, or Impala to sit on top of Tachyon to leverage the performance, in-memory performance. And then we want to also sit on top of existing these source solutions like HDFS, S3, local file system, GlassFS. We support all this now, and there are companies working on this like NFS or self-integration, and we will see them in the future releases. And different companies use it differently. So for example, some company use with HDFS, some other company use with S3. And also, of course, we welcome all the collaborations from different partners. And this is a really short-term roadmap. So for next release, we'll have the self-integration. This is from Red Hat. And also, we'll have the hierarchical local storage solution. This is from Intel. And we'll have the further performance improvement to work with framework at Shark. This is from Yahoo. And also from AMPLab, we have other like multi-tenancy support. Also, we have many more exciting features from AMPLab and our collaborators. And of course, we will value your requirements. So feel free to let me know what's your requirements. Like say, for example, there are some people asking to run this with MapR's file system in our forum, and they have seen the performance gain for that particular combination. Okay. So this is a short summary of the system. So Tachyon is a high throughput, fault-tolerant, memory-centric storage system. and with Lineage as the first-class citizen. And also, it further improved the performance for frameworks like Spark, Hadoop, and Sharp, and others. And we have a healthy community with more than 15 companies contributing, and we are welcome more. And for more information, you can visit our website and our GitHub, and you also can feel free to email me for any question. That's it. Thank you.
HY, do you know, can you talk about, I mean, I don't know if it's under NDA or anything, but can you talk about like what specifically Yahoo or, you know, some of the other companies, how they're using Tachyon, you know, and what business unit or, you know, what research area or, you know, what's the use case there?
I see. So I need to make sure about this. But for some company, they run this like for their like ads department, and they build this as the frame they run Shark on top of Tachyon in this particular case. So then basically they put the data in Tachyon and then do the Shark query, and their BI guys will run the Shark query for this cluster in this cluster. Or for some other case, like for some company, they run Spark on top of Tachyon, as I said in the previous slide. Yeah, and also that's the framework side integration. For the underlayer side, there are companies to run on top of HDFS. There are also companies run on top of S3 directly. As I said, from the user mailing list, there are also companies running this with MapR. And I think some people are trying to push this into the HPC community too, and to run on top of GlossFS or some classes like Orange file system in HPC world.
You mentioned one other thing. You mentioned that the average Hadoop utilization was 30% in the interview.
That's the report saying that average cluster utilization nowadays is around 30%.
Is that because there's so much, what's the word you use, the data is replicated so many times within Hadoop?
So basically, so a lot of companies, their workload is not even all the time, right? So sometimes they have a peak, sometimes they have a, not very crowded workload. In that case, they have to provision their cluster for the peak workload they can have, right? Say for example, like Amazon before, or a lot of internet companies, they have this kind of workload. Yep.
So you were comparing the performance against Spark before. Were you comparing Tachyon on Spark on top of Tachyon, or?
Yeah, it's either Spark on top of Tachyon or Spark without Tachyon. Yeah.
Okay, so both of them are Spark shops. Okay.
Yeah. But different mode, how to run them differently. But back to your use case question, I think so. There will be a Tachyon meetup from August, and we will line up several use case talks.
Excellent.
And let them to talk about the details.
Yeah. I saw that you're also speaking in Strata in the fall.
Yeah, that's October in New York City. Yeah, maybe Tachyon talk. Thank you.
So if you can fully cache your data for whatever Spark job you're running, is there any benefit to this? Or?
Yeah, sure. So basically, the question is, if you can fully cache your Spark data in memory, why use this system? So this back to the original motivation from these several issues, right? Say you have a pipeline in a company, and normally the pipeline is written by different programmers. You have a huge analytics pipeline. So it's hard to be one single program. Probably you want to have different programs. That's the case is this issue one. Basically, how do you share the data inside the pipeline? The other issue is, one other example could be, this is issue two, like say this issue 3, you have 2 jobs, right? Maybe written by 2 departments inside the company. You want to analyze the same input data, but for different use cases. In this case, it's hard for them to share the same program. So that you can also leverage Tachyon to put one single copy of the data inside the Tachyon, and then write 2 Spark applications to load the same input data. So in this case, without Tachyon, you have to put this data you have to duplicate the data into different Spark processes. So that's the benefits.
But let's say, you only have one Spark job running against one data set.
Yeah.
But if you run it through Tachyon, you need to go through ANI, copy the data, deserialize it, do all kind of stuff.
Yeah.
So what is the impact on this kind of?
Yeah, that's a great question. Basically, you're saying you only have one Spark job if your use case, and in that case, if your data is small, you have a much more memory than your data size. In that case, maybe I don't think you need Tachyon. At least for now, you don't need Tachyon. But in this particular graph, this is exactly the case you said. Say, when you increase the data size, you probably won't use Tachyon, right? So you can handle more data with less GC overhead, even for simple like one application case.
So how about the overhead on the JNI?
Yes. So actually, Tachyon doesn't use JNI. We use the NIO from Java 6 or 5. They started to support NIO. It's pretty fast, and so I wouldn't say the loading the data from outside the process is the key bottleneck now. There are other bottlenecks, so it wouldn't be a huge problem. But you can see from this figure, if your data is small, right? In this case, loading data from Tachyon definitely will have more overhead. But as I said, if you increase the data, say in this like 30 gigabytes, this Spark 1 mode will not work anymore. And here, like 80 or 70 gigabytes, like another mode without Tachyon doesn't work.
So
either.
What's the reason that there's those spikes?
Yeah. So basically, for this first line, for this first spike, the reason is that if you cache the data in Spark deserialized mode, that will cache the Java object. The overhead for the Java object is really high. One is the memory footprint. Say for example, even though you only have 40 gigabytes raw data, but inside the JVM it may take like 160 gigabytes in memory space inside the JVM. So and then whenever this GC, it's done. So it take a minute. There's no performance guarantee from that point, right? So that's the first line. The second line is that so when you want to load a lot of data from outside of the process into the JVM, so then you will have the condition that say half of the machine you have the data, they already store some data for OS buffer cache. In that case, OS does a pretty bad job to transfer the memories from the OS buffer cache into your process. So that's the reason for the second line. And also, you also have more garbage collection. Like this dot line is garbage collection overhead. We print it out from the GC log.
It's not because you ran out of memory. It's because of garbage collection and.
So it's both. It's both. Yeah.
Did you actually run out of memory during the test? Like,
so for this case, if you increase it, yeah, that's a reason. But also in this case, you can see the dot line is overlapping with the solid line, right? So in that case, you have an extremely high GC overhead.
Okay. But this is one machine.
Yeah, this is one machine too.
Okay.
The reason why I show this graph is to explain exactly what happens in the very simple case. So then we can know what will happen, But it's a great question.
Can you bin data sets in memory?
Say again?
Can you bin something in memory so it doesn't?
That's a great question. So the question is whether you can pin a data set in memory. Yes, and also we improved the feature from 0.5 release. If you go to the 0.5 release note, you will see this is a pretty big feature here. we can pin and unpin a folder, a file, anything.
And can you prioritize things so that when you flush things out,
Yeah, that's
some things get flushed
yeah.
out less?
Yeah. So the question is, if your memory is not enough, what's the data eviction policy? So for now, we have a simple LRU policy, but from 0.6, we will have a hierarchical like storage on every single node, local storage, and then we are going to provide more like eviction policy. We're also going to make this like pluggable. Basically, we have some common like policy there you can choose, and also the user should be able to implement policy for their own workload.
How to deploy Tachyon? So
I'm sorry?
How to deploy
How to deploy Tachyon? Yeah, so there are different ways. In our documentation, we have the way like say, we have a single script. You just call it like command line, one command. Basic step is you put a jar on every single machine and use one command, like starting like same as starting Hadoop MapReduce or start Hadoop HDFS. The other way is from Spark 0.9 1 maybe, or from 1.0, Spark provides a script. You can really also deploy Tachyon with one command from a Spark release.
So you have to literally copy the script and the jar files into every node in order to
Yeah. So
run.
basically, there's a bin tar ball from the Tachyon website. You just download that tar ball and unzip it, and then put that on every node. Should be done. Yeah. Yeah. It's just one command to start it. Actually, two. Yeah. One is format. The other one is start. Yeah.
So you also mentioned that on one of your slides talking about the hex data use case.
I'm sorry?
You showed a hex data use case.
Oh, 0x data.
I think they pronounce it hex data.
Oh, maybe. Yeah. I don't know how to pronounce it.
So they're trying to move the data from Spark between Spark and their.
Actually, this is from So the question is, what do they do? So basically, this is a snapshot from a Databricks blog, and this is authored by Hex Data.
I see.
Yeah. So in the blog, they mentioned that you share the data between exchanged between Spark and H2O via Tachyon. So that's they share the data this way.
Because their data is their platform is also in memory, which is different from the Spark. So it's curious.
Yeah, I think what they do is they use Spark to process data for some workload, and then we use their framework to process data for some other workloads. Yes. And use Tachyon to share the data in the middle.
HY, for people who aren't as familiar with like the Berkeley data analytics stack, do you want to give kind of like some background just overall on the project, how it started and where you think it's going?
For this particular project, or
for Tachyon, or just for the entire project, I would say, like how do things look over there? What's the latest? There's been a lot of news about Spark, obviously.
Yeah.
Spark some last week.
Yeah.
How do you see it, I guess, from your point of view?
So I can only see Tachyon part. For the BAS part, I can only talk a little bit about history, about the fact. Basically, our lab has a stack called the Berkeley Data Analytics Stack. You can call it BAS. So BDAS. So then that stack has we do from a cluster resource manager, that's the Mesos, and then we did Spark, that's the data processing layer. And on top of Spark, we have different framework, different library for different frameworks. Say Spark Streaming, Spark SQL, Spark GraphX for graph processing, and also machine learning library. So then we have this system called Tachyon for the in-memory storage. That's the whole stack, and the Spark and Mesos. They are pretty mature nowadays, and also they already graduate from Apache incubator, become the top level project in Apache. So and also Tachyon is our relatively new project nowadays.
What does it take to become a top level project in Apache?
So what takes to what
does it take to achieve that? I guess. Like
I see.
Do you see what do you see? Do you see Tachyon basically achieving that one day, or do you think it's an easy thing, or do you think? Just curious, because rarely do you get to talk to them.
I see. So I think it's possible for Tachyon to become a Apache like foundation project. Now it's in Apache license, already in Apache license. So I think in order to achieve a Apache top level project, it's just follow their procedure. They have a website to talk about procedure. You have an incubation process, and then you follow the rule, and then they will judge whether you can graduate or not based on their criteria requirements.
I'm curious about it, since Spark tries to do everything, including the graph, machine learning, streaming, Spark SQL. So why Tachyon doesn't want under the umbrella of the Spark?
Tachyon want on the what?
On the develop within Spark, because it's easier and also Spark really get us traction. So why Tachyon don't want to become part of Spark?
Oh, I see. The question is, I see. So fundamentally, Spark is a processing framework.
Yeah.
And this is a storage layer. It's different layers. You see, that's the fundamental thing. And also, we definitely want to support Spark very, very well. And also in the meantime, if there is needs from other requirements, we also want to help. So it's like HDFS, right? You can run lots of different things on top of HDFS. It's not,
So the non-iterative MapReduce jobs.
I'm sorry?
With non-iterative, as it's
Okay.
a short map.
Okay.
Would Spark have any advantage over a standard Hadoop MapReduce job? Because
so that's from the various Spark application talks. I think there are, but because there are some architecture difference, and also implementation difference, and it could easily become several X difference performance difference. Yeah.
Are there fundamentally new things that you can do at Tachyon that enables you that you frankly weren't able to do before, or that you wouldn't be able to do without Tachyon? I mean, you showed the graph of essentially performance-wise, but when you look at that, whether it's cost of ownership of Hadoop, or it's your analytics stack, or it's being able to basically do some sort of analysis that would have been very difficult. Spark's enabled a few things, or do you? I mean, it's probably hard to guess, but what do you see from a vision standpoint? What do you think that could enable for businesses or organizations or society in general? Kind of a big question, I know.
Thank you for the question.
Yeah.
So the question is, what potentially the system like Tachyon can enable?
Yeah.
So it's pretty hard to answer. So I think the key thing for this system is, so think about the future, in 3-5 years, the memory of every single machine will be huge, right? So we want to do, Tachyon want to do this in-memory storage really, really well. That's the goal of the system. And then to facilitate other components in the step, right? Say in this particular case, want to have different things running on top and below, right? So it's hard for me to really predict whatever new application on top of this, but I guess there will be new things enabled, same way Spark, because you have some one order or two orders of magnitude performance gain, enable a totally different user experience. Therefore, you have different product. right? So previously you couldn't do interactive, now you can. Or previously you have to, do separate stacks. Now you can do everything in one stack, right? So in this particular case, I would say only the time will tell. Yeah. And we encourage like innovative programmers, developers to build more things on top of this.
So is Tachyon a transparent layer? When you're writing a Spark job, do you have to call special API, or is it?
No, it's not a. It's not a. So there are two ways for Spark now to use Tachyon. Here, one way is you just you see like you load input data. This is nothing really changed. It's just the URI
So if you do that, you don't have to cache anymore.
So then you call this command, and then it will cache for you. It's transparent.
Yeah, but I have to do file.cache.
So, I see, file.cache, right?
Yeah.
So that we say, for example, Tachyon has the say for the ping operation, Tachyon has the command line tool. You can do the CLI tool, and also you can write your own application using Tachyon's API directly without going through any framework. It's a possible way, and
So
yeah.
If you do that, do you still have to use Java? Is it still Java based?
Now we only have a Java client library you can use, but we do our RPC through it. It shouldn't be very hard to have other language.
So is the memory Java heap, or is it?
No, it's off the heap.
Oh,
so
it's
the
native.
Yeah. So all the data is stored. The real data is stored in the RAM disk, and the Java process only store the metadata, which is pretty small.
Okay. Yeah, it would be nice if you provide like C++ interface or something.
Yeah. So actually, there was one person just filed a Jira today to support C and Python, and he assigned a task to himself. Yeah.
That's nice of him.
Yeah. Yeah.
Cool. Thanks so much, Haoyuan. Anyone else have any other questions?
I have one. So,
Sure.
So you mentioned the multi-tenancy. So does it mean that I can leverage on multiple clusters or nodes, in the future?
Oh, so for the multi-tenancy, basically means that you have still our context now is like one cluster, but you have different users on different applications.
Okay.
See, this is the same way now. You have a say MapReduce job. You have user A, user B, user C, in different groups.
How does Yarn, I guess, because Yarn kind of serves that purpose to a degree. I mean, not as deep as you do, but it kind of is the application manager.
It's different layer.
Yeah.
Yarn is like Mesos.
Yeah.
Yeah, it's like the cluster resource manager.
Yeah.
So they do they do memory and processor allocation for applications, right?
Mm-hmm.
But for us, we manage the storage. So that's a different layer. Yeah. Yeah.
So different file systems are, I know, within your sights of porting this over to, not just HDFS. Which file systems are friendly to working with Tachyon? Because some work with blocks, some work with files, and some are more object-centric.
I see. This is a great question. So Tachyon has a very simple interface to integrate with on the layer file system. So anything implement at that interface should be able to. We can work together. In terms of performance, as you said, so different storage systems, they have their own properties. We haven't really done a detailed work on analyzing that yet. Yeah. But we need to see what's the workload and whether that workload can take advantage of this thing. See, for example, if your workload is everything just one time, it doesn't really help. Yeah.
And HDFS is often an amalgamation of lots of small local file systems. With the
Yeah.
Is there any point to having a cluster file system underneath Tachyon?
Yeah, HDFS could be one. Yeah, that's right. So from this figure, basically, this figure, you can see that. So under that, so it's all the cluster file systems.
So Ceph is an interesting one because it could be block, file, or object.
Yep.
So what's the intent of interfacing with Ceph? At which layer would you interface?
So Red Hat is leading this effort now. So say they also did GlossFS. They use their file system API to do this integration.
Okay.
Yeah. But I can also imagine that for some particular use case, another like API could be better, but need to be explored.
It sounds like it's primarily at the file system layer, or the file object layer, that you're interfacing.
Yes.
Okay.
Yeah. For now, yes. Yeah. So the interface is more like that now. Yeah.
Last question.
Sure.
Doesn't the OS also do caching on the file? How does that exactly interfere, or why does that
Yeah.
have to work with Red Hat?
That's a great question. So some other people asked the same thing like on Twitter several days ago. So the question is, what there's an OS buffer cache. Why do we need this, right? Or what's the difference?
I've been told that in my organization,
Oh, okay.
so I don't know the answer.
So basically, this is the same way like how you can imagine that for OS buffer cache, it's designed for the general workload. It's not for the big data. It's not for the database, right? So this is the same as like you have database DBMS, right? So they have their own like memory management tool inside of their system to do the fine-grained memory management for their workload. The same thing here for the big data workload or for whatever other workloads. That's also the same reason that why we want to provide different policies in the future, not just the LRU, right, to fit your workload, right? So OS buffer cache is really hard to tune for this big data workload, you know. It's also not designed for this.
So Tachyon has, basically you said it has this master node, that's the master. Is that become a single point of failure?
Yeah, this is a good question. Whether Tachyon has a single point of failure for the master. So the answer is no. So we use Zookeeper to do the leader election. Yeah, so like here. But we have a hot standby masters for you to deploy. And if the leader got like something got crushed, right? So the standby will take over like immediately.
Is this also immutable structure? Like, can you modify the structure? Can you modify the memory stuff, and will that still be fault tolerant?
Also, if you can modify the file.
Yeah, not the file, but you could actually modify the in-memory data. Like in Spark, you could cache the data, and you can modify RDD structure.
Oh, you're saying to transform.
That breaks the fault tolerance of Spark.
Oh, I see.
Yeah.
I see. So whether you can do the update in this case.
Yeah.
Right?
Yeah.
So for now, you can't.
Okay.
Yeah. If you do that, yeah, now you can. Yeah.
You load the data through NIO. You load the data through the OFF HEAP NIO
Yeah.
through Java. And
Yeah.
You modify. What you modify is just the data inside the Java process.
Basically
Not
now,
going back to the-
yeah, basically now we don't provide the API for you to modify that. So it's basically write once and read multiple times. Semantic.
So does the network come into a heavy impact on how this performs?
It really depends on the workload. Yeah. For some workload, if you have a lot of shuffles, it will be a bottleneck, and we are also investigating that. Yeah, see what kind of network thing we can do to really push the performance further.
It would seem like RDMA would fit in here very well.
Yes. And there are many interests from different parties about like how RDMA can work with this kind of a thing together.
And how do you handle writes? Do you copy the data to different nodes before you acknowledge?
So this depends on which mode you use, as I said. So for the lineage mode, you only create a lineage, and then for the write, you only run a single copy. But for other mode, like you want to do synchronize, like write through, basically besides writing Tachyon, you also want to write to the under file system, like HDFS 3 at the same time. For that, we just put the data at the same time into the under file system. If the under file system is done, we acknowledge it's done. Yeah, and then the fault tolerance in that case is provided by the under file system, like HDFS 3.
That sounds slow.
Yeah, yeah, for that mode it's slow. Yeah, it's the same as those systems, the bandwidth those systems provides.
So can you maintain multiple copies of an object or a file within Tachyon on different nodes?
Yeah, you can. Depends on the workload. What we do now is called client-side caching. So now, for the first time, you only load one single copy into one node, right? So later on, if the data is really hot, you will naturally have more tasks requiring data from different nodes. And then the client-side caching, what it will do is to load the data into those nodes too. So then, in the future, you have many nodes containing the hot data, so you don't have that hotspot issue.
But if you're doing a write, is there any facility now or in the near future so that I can put that write on another node before and acknowledge that way rather than waiting for the underlying file system?
Yeah, that's a good question. So for now, we don't have that yet, but it's on the roadmap.
Okay.
Yeah. Yeah.
Well, if there's no more questions, I want to thank Haoyuan for coming to Alpine. And yeah, thanks, man. That was really cool.